Hi everyone, welcome back to Geekster's YouTube channel. So today we are again going to have a free masterclass for everyone. And today's topic will be a data structures and algorithms concept, which is how we can design our own stack and our own queue. So we might know what is a stack, we might know what is a queue in real life, but today what we are going to see is we are going to implement a stack, implement a queue, and we have to see that what all various methods we can apply in order to implement a stack, similarly in order to implement a queue. And once we know how to implement a stack and we know how to implement a queue, so if time allows us, so we can discuss some problems which we can solve on these two data structures, or we can have some follow-up sessions and I can give you some homework questions based on designing of stack and queue. So first of all, let us start with my introduction. So about me, my name is Archit Agarwal. I am a software engineer intern. So basically, I have done the internship at Salesforce as a software development engineer, SDE. About 14 months experience I have currently in edtech industry, basically teaching students about data structures, algorithms, object-oriented programming, low-level design, system design, and all those. So I have almost like taught 1,000 plus students, even in fact more of them. But you can say roughly I have taught about thousands of students in various institutes. For example, web coding. I used to work at web coding. Then I got to work at Interviewit or Scalar, and similarly at Unshop. I'm also a competitive programmer, so I have achieved like expert rating at Codeforces platform. It is a competitive programming platform, and I have done a computer engineering degree. I'm currently pursuing it at GTU. So like this BTech degree is about to complete. Anyways, so this is about me. What we are going to see, we have discussed it. So let's start. Let's start. Let's directly jump into the topic. So first of all, we are going to design a stack. So what is a stack? Stack is nothing but a pile of objects, we can say stacked on top of each other. A pile of objects which are stacked on top of each other. That is, if we say a pile of books, so how are pile of books stacked on top of each other? For example, there is a book which is of C++ or maybe C. Then on top of the C book, there is a C++ book. Then on top of C++ book, there is a maybe Java book. On top of Java book, there is a Python book. So this is nothing but a pile of books. And how we form it? We form it using a stack. Why? Because if we want to remove any book, if we are not doing some magic trick, obviously we are going to remove the topmost book, that is Python book. Then we are going to remove the Java book. Then we are going to remove the C++, and similarly last one will be the C book. So insertion of books was in the order. First C was inserted, then C++ was inserted, then Java was inserted, then Python was inserted. So insertion order was from top to down. That is, first C was inserted, then C++, then Java, then Python. So insertion order was from top to down. What that is top down approach. And how we are going to remove the elements? We are going to remove elements from the topmost book first, then the second last book, then the third last book, and the last book. Actually, this is the first book which was inserted. So now it is the last book which is going to be removed. So insertion order will be from top to down. Removal order will be from bottom to top. That is, we are going to remove first this, then this, then this, then this. So it is like we are removing from top, and then Java, then C++, then C, and so on. So removal order is different. In the order in which we are inserting the elements, it is different from the order in which we are removing the elements. If we are inserting C, then C++, then Java, then Python. So if we are saying this is the first element which is inside the stack, this is first element which is going inside the stack, and this is the last element which is going inside the stack. So which is the element which is going to be removed first from the stack? The element which was inserted first, or the element which was removed inserted last? Obviously, the element which is inserted in the last position will be the element which is going to be removed first. So we can say the element which was inserted in the last in, was removed first. So last in, first out, or vice versa. We can also say the element which was first inserted is the element which is going to be removed first. So first in, last out. The element which was first inserted, it is going to be removed in the last only. First Java, the Python will be removed, then Java will be removed, then C++ will be removed, and finally C will be removed. So order of insertion is different from order of removal, although the insertion and removal both are from same end only. That is, we insert from this end only and we remove from this end only. The direction is changed, but the insertion order and the removal order is just from the same end. We do not say that we are inserting from bottom. We are not saying we are removing from bottom. We are always saying we are inserting in the top only and we are removing from the top only. So both the insertion as well as removal are from the same end only. So this is nothing but a stack data structure. So what are the various ways in which we can implement a stack data structure? There are basically three ways in which we can implement stack data structures. What are those three ways? The three ways to implement a stack data structure can be a simple array. We can use a simple array. I guess we all know array by this point. So a simple array can be used to implement a stack data structure. What else? We can use a dynamic array, which is basically in Java, it is array list. In C++, it is vector. I don't know in Python what it is called, but I am writing it as array list. That is, we can implement the dynamic array. We can have an array which is growing in size, shrinking in size dynamically. We do not need to give the size to the stack. Stack can grow in size according to the needs. Stack can shrink in size according to the needs. If we insert a lot number of elements, so stack size will grow. And if we remove a lot number of elements, so stack size will accordingly reduce. But in array, it is a fixed size array. This is generally fixed size. So when we say fixed size, what it means? If we have to declare an array of 100 size, it will remain 100. That is, we cannot insert 100 first element in the array. It is of fixed size. Similarly, we cannot say that I do not require 100 elements currently. I only want maybe 20 elements. So I cannot shrink the size. Once the array is fixed, it is fixed. It is memory wasted also. And also you cannot say we can grow the size of array. We have to create obviously another array, but array list we can do it. We can do it easily. And what is the operation time complexity? What are the different operations time complexity? Insertion in the last is always constant. It is amortized constant time complexity. You can say it is constant time complexity. Insertion in the end, that is, if we want to insert any element in the end, whether the array size was 0, whether the array size is 100, every time the insertion will be constant operation only. And if we are saying what about removal, so similarly removal from the end also will be constant operation. Removal from the end also will be constant operation only. So both the insertion and the removal from the end, from the last index of the array list, is going to be a constant operation. So if I ask you, I want to implement a stack using array list or using array also. So from which end in array list particularly we are going to remove the elements or insert the elements? Obviously from the last, because insertion in the front and removal in the front in array list, it is not constant operation. In array list, removal or insertion from the front, it is not constant operation. Hence, what we are going to see, we are going to not implement array list by inserting and removing from the front end. We are going to insert and remove from the last end. So this open end is going to be the last index in our array list. In array, we can implement it anyway because anyway it is fixed. So we can start from the left and go till the last index, or we can start from the last index and go till the front index, and we can have a pointer pointing to the array index, whichever is going to be removed or whichever is going to be inserted. At whichever index we are going to insert the element, we are having a pointer on that index. So essentially, first we are going to implement array, that is fixed size array implementation of stack. Then we are going to implement dynamic type of stack, that is we can grow the stack size, we can shrink the stack size according to the needs. And third type is also a kind of array list implementation only, but it is using linked list. It is using linked list. It is also dynamic. It is also, we can increase the size, we can decrease the size. But if we know what are the differences between array and linked list, or array list and linked list, then we know that array list is contiguous and linked list is not contiguous. It is like, it although it is linear, but every node is not stored one after the other. It is not stored in a contiguous fashion in memory. These are discontiguous blocks which are stored in different locations in the heap memory. So anyway, we can implement a stack using array, we can implement a stack using array list, or we can implement a stack using linked list. So we have to know the collection frameworks because we are going to use array list also. And obviously for linked list, you can use the collection framework, or you can have a node node type data structure of your stack, which is going to store the next pointer and which is going to store the data. So first let's start with array. So let us assume we have a array of 5 sides. So array implementation of stack. We are going to learn about array implementation of stack. As we know, the array is of fixed size. So let us say the array size is maybe 5, n is equal to 5, where we cannot create a array. We cannot create a stack of more than 5 size. Why I'm taking 5 size? Because 5 will be easy to basically dry run. We will be easily able to dry run the code if we are having a smaller size stack only. So array is fixed, hence we are having a 5 size array, and n is equals to 5. Initially, all the stack will be empty. Entire array is empty if this is ARR. The class of stack, we have to know a little bit of classes and objects here. Although if we do not know, then it is still good enough, but more clarity will be there if you know what are classes and what are objects. So in the class of stack, where we are going to implement the push and pop logic, where we are going to implement the push and pop logic. What does push means? Push means insert in the stack. This operation is nothing but push operation. Pop means we are going to remove from the stack, and both push and pop will be from the same and last in first out. So what we are saying, push operation, pop operation, what element we have to push? Currently we are assuming it is an integer. What element we have to pop? Whatever element we are going to delete, we are going to pop it and we are going to return it also. So integer return type will be there will be no parameter. So whatever the integer stack contains, I will return the topmost element. So both push as well as pop is from the top and only. So I can assume in the stack, in the array implementation of stack, I can assume the top from as the first index, or I can assume the top as the last index. It is your wish. So let us assume maybe the top can be the last index, because if we are saying we are inserting from this end, and removal is also from the same and only according to the stack logic. So if we are inserting from the front end, obviously the first element which is going to be inserted will be the last index. Why? If we are assuming this stack is like tilted, it is rotated. So the element which we insert from the top, it will go down towards the last index. It will just go down towards the last index. So if we are going inside, if we are going inside from the zeroth end, from the top end, from the front end, we are going to be inserted first at the last index, then the second last index, then third last index, then fourth last index, and similarly zeroth index. So the top will be moving the top index. This is the insertion order. This is the push operation. So the top index initially will be pointing to the last index. Why? Because we are inserting from left to right. So left to right insertion means we are not inserting zeroth index first, then first index. Because if we insert from this order, the first element which is going to be inserted will go down to the fourth index, will go towards the rightmost index. And similarly, the pop operation will also be from the same and only according to the logic of stack. So let us start. If we are saying we want to push a value which is 10. So currently is the currently top will be n minus 1, last index. So is the top pointing to a valid index? Can we push an element in this? Yes, we can push an element in this. So we can insert 10 in this index. And since now this element is pushed, this index is not free. It is not free now. It is filled with the element 10. So we can make the top pointer minus minus. If I want to say I want to insert 20, so where should I insert? I can insert simply at the topmost index. So insert 20, and since this index is filled, we can do top minus minus. If we want to insert 30, so I can simply insert 30 and I can say top minus minus. So what is it doing? What we are doing in push operation? We are saying first insert the element in the array of top at the topmost index, insert the new value which is going to be inserted, and do top minus minus. Now, if I want to insert 40, we can insert it. I want to see a corner case. So top minus minus after inserting 40. Finally, four elements are inserted. Fifth element, the array size is 5 only. So we can insert only 5 elements at a time. Maximum 5 elements can be there. So as soon as I insert fifth element, that is 50, I will insert 50 at array of top. Array of 0 will become 50 and top minus minus. So 0 minus minus, now top will become minus 1 index. But now, as soon as the top is becoming minus minus, I can say I can no more push any element. If I want to insert 50, if I want to push 50, I cannot do it because the index is minus 1. Already the array is fixed because arrays of the stack implementation is of array only. So if top is becoming minus 1 index, if top is minus 1, we cannot push any element. So currently we can return. Although if we know about collection frameworks, so Maybe we can also know about exception handling. So if we know exception handling, we can throw exception here, but no problem. Currently, even if we are returning, it will be good enough according to data structures and algorithms requirement. Okay, so we cannot insert any element because जो top है वो already -1 है. The top is becoming -1. Now let's discuss about pop operation. Let's discuss about pop operation. So if we want to delete some elements, so where, from which index, from where end, the left end or the right end, from which end is the element going to be deleted? Obviously, the element which was inserted in the last in will be the first out, last in, first out, or first in, last out. So the first element which is going to be deleted will be 50. So how can I delete 50? First, I cannot make the top pointer get deleted. I can simply say what? I can simply say top minus minus. What does simply top minus minus means? Top minus minus means if I want to now insert a element which is 100. So where is the element 100 going to be inserted? It is going to be inserted at array of top. So array of top will become, array of 0 will become 100 and top minus minus. So assuming top minus minus is nothing but deleting the element, we can assume it, or we can make the index back to 0, but it is your wish. If you want to make the index value back to 0, it is your wish. Even if you make it stay 50, still it is good enough. I am saying if in pop operation, if we are only doing top minus minus, then it is also good enough. And as soon as you do top minus minus, you can return the element because it is also expecting a return type. So array of top, the element which was deleted was the top index only. Now after top minus minus, if I am deleting, the top was pointing to 0, -1 index. I want to delete the topmost element. I want to delete 50. So first I did the top minus minus, and now I am returning 50, and I am assuming 50 is deleted. Why I am assuming 50 is deleted? Because if I want to insert 100, it will insert at the topmost index only. Okay. So let us do some more iterations. I want to delete one more element. So essentially 50, you can assume it is deleted. I'm just logically showing it is deleted. If I want to delete one more element, first, the element which is going to be deleted is what? The topmost index, 40 element. But topmost index is not pointing to the topmost index only. The top pointer is not pointing to 1. First, make it point to 1 by making top plus plus, not minus minus, but plus plus. Sorry, it will be plus plus. We are increasing the top pointer. And after making the top pointer plus plus, we can say 40. It is deleted, but we have to return it also. Okay, so return array of top, return array of top. So we can assume 40 is deleted. Again, delete 30. So first do top plus plus, not minus minus, and delete 30. We can assume it is deleted. We can make it 0 also if you want, but we have to return it currently. So we are returning array of top. So till which point it will go? If I want to delete one more element, so top plus plus, delete 20 and return 20. Top plus plus, delete 10 and return 10. If I want to delete one more element, first what you are going to say? Top minus minus. Sorry, top plus plus. So top plus plus will make it what? 4 plus 1. It will make it 5. So 5 is nothing but array dot length. So when top is pointing to the last index and I want to delete one more element, we can say array is already empty. There is no more element which is to be deleted. 10 was the first element which was inserted. So there is no more element. So if a top is pointing to the last index, we cannot delete any more element. We cannot delete any more element because there is no more element in the stack. So top is n minus 1. We cannot delete. So we can return maybe -1 in that scenario. This is according to the question that what are they expecting us to return. So currently we are returning -1, that we cannot delete any more elements. Stack is empty. This is the scenario when we can say the stack is empty. And this is the scenario when we can say the stack is full. But full scenario will only, most probably it will only occur if we are using a static array, that is fixed size array. If we are using a dynamic array, that is array list, the full scenario is not going to be achieved, or it is going to be hit if we are having a lot larger array list, like 10 to the power 6 size, 10 to the power 7 size. That much big array list might give you a full exception, like array list full heap memory overflow exception. But that is not a simple scenario. That is like when you create a lot bigger array list. This much, like this much small array, why we are getting a full queue exception, full stack exception? Because the stack size was only 5 elements. So we cannot insert any elements more than 5, any more elements after 5. Okay. So let us implement this same question. The same question we are going to do it. We are going to solve it on the implement stack using array. We are going to solve it on implement stack using array. So the question is on GFG. I can share the link in the YouTube's description. But according to the question, they are saying top is equals to initially -1. So let us change some part because it is our own wish where we are going to start. So according to the logic, where we started the top from n-1 from the last index. So we are going to start the top index from last index, that is array dot length -1. And also you do not need to change the part which GFG is already providing us. They are providing us already the array dot length is 1000, so we should not change it. Maybe they are saying us that the maximum elements which are going to be inserted will be only 100. So let us do not change the array size. Let us make it 1000 only. This is not what I have written. This is by default given to me by GFG. Okay. So if I want to push any element, if I want to insert any element, where it is going to be inserted at the top index. And according to the logic, what we have seen, if top is -1, we cannot insert any element, so we can return. Otherwise, if we have to insert the element, where we can insert, we can make array of top as directly value, and we can say top minus minus. We can say top minus minus. This is what we have doing, what we are doing. In pop operation, as discussed, when is the scenario for underflow? If a top is already n-1, there is no more element which can be deleted because stack is empty. So we can return -1. According to the question, they are saying return -1 from the pop operation if the stack is empty. So we are returning -1. Let us write a comment also that this is empty. Empty overflow, like stack underflow exception. This is the scenario where we are having a stack underflow. We cannot delete any more element. This is a scenario where we are having stack overflow. So if top is n-1, we cannot delete any more element. Otherwise, first make top plus plus and now simply delete the element by saying return the element and assume it is deleted because we can overwrite the value. You can also make array of top as 0, but simple enough implementation will be simply make array of top return and we can say top plus plus because top plus plus actually means we are deleting it. Because if we want to insert any element now, all the 10 is still there. All the 10 is still at the port index. If we want to insert 100, so we will overwrite the value of top index. We will make the top index as 100. So we are going to overwrite it anyway. So there is no point to make it 0. Okay, so there is a compilation error. What is the compilation error? N is not defined. No problem. So let us take array dot length. Now let us try. And what is this? Maybe some of you might not know. This is nothing but a constructor. So if you do not know about constructor, you can simply initialize the top here. You can simply initialize the top here by saying 1000 -1, which is 999. And you can ignore this line. You can ignore this line. So if you do not know constructors, there is no worries. Now there is nothing like constructor. There is nothing like classes and objects. You even if you do not know classes and objects, this code is perfectly fine, I guess. So let us submit. Why it is 999? This is n-1. This is pointing to last index. Pointing to last index. Okay. So let us bring this code in the open board. And what is the time complexity? I ask you, the time complexity of both push and pop operations will be constant. Obviously, we are just simply updating the array values and we are just simply making top plus plus or top minus minus. So these both operations in a stack are nothing but constant operations. Per push is constant, per pop is constant. Like one insertion, one removal is constant. If we want to n elements insert, if we want to insert n elements insertion will be constant into n, which is order of n. If we want to delete n elements, that is delete all the elements from the stack, it will be order of n again. So this is for one insertion or for one removal, constant operation. I hope the simple most implementation of stack is clear. That is the first part. Now, second part, the array list implementation. So let us go to the array list implementation. You can pause the video, you can try it, although it is going live on YouTube, but still you can pause the video if you want to try it on Geeks for Geeks. And then we are going to solve the same question using array list now. We are going to submit it on the same question only. Although the question asks us to have an array of 1000 size and it is having the question name implement stack using array, but I have not found any question which is implement stack using array list. So we are going to implement it in the same question only. So array list implementation of stack. Array list implementation of stack. So how we are going to implement array list? See, array list we already know. Array list we already know. We need not implement array list, because if we want to implement stack, we assume array list we know. We have to keep it abstract for us, that even if we do not know how array list works, still it is fine for us, because currently the agenda is not designing array list. The agenda is designing stack. So we are going to assume we know the array list, we know the syntax of array list, we know how to insert elements, we know how to pop elements, and as discussed, insertion and removal from array list will be from the end operation, from the end index, last index, because both insertion and removal from the last index in array list is constant operation. Okay, so again, same thing. If we want to push elements, initially, how will the array list look like? Array list will be empty. So array list will be of zero size. The capacity will be different, but actually the number of elements in the array list will be zero. So array list of integers ARR is equals to new array list. Initially, it will be empty. There is no need to have a pointer top. There is no need to have a size variable with you, anything like that. So only what you need to do is just implement push and pop operations. By doing what? Push means insert in the last index. Pop means remove from the last index. So push means simply just insert array list dot add the value, and add will actually insert in the last only. It will be constant operation. Pop means delete from the last index. So delete from the last index means just return. Just first store the value. We cannot directly return it. Just first store the value, that is int val is equals to array dot get array dot size minus one, array dot size minus one. That is first get the last element from the array list, last index element. And now once we get this element, we can delete the last element from the array list. That is array list dot remove may be the operation. I'm not sure what is the function name, but let us try. It will be remove most probably. So array list dot remove the last index. Array list dot remove array dot size minus one. And now we can return the val. And also we have to do the exception handling, the corner case. That is, if array dot size is zero, if there is no element in the stack, that is array list is empty, so return minus one. If array list is empty, if array dot size, if it is zero, we cannot delete any more element. We have to simply return what? We have to simply return minus one. So how is this working? I have directly written the code, but maybe you were uh, getting the logic. It is not rocket science or something. If you know array list, this implementation is very easy. So what we are saying, initially the stack will be empty. Initially the stack will be empty. Stack is using array list. We are implementing it using array list. If we are saying insert 10, okay, no problem. Array list, which is initially empty, insert 10. So insert 10 in the last. If we want to insert 20, so array list dot add, arr dot add 20. Okay, dynamic array. The size is changing. If we want to insert 30, no problem, insert 30 in the last. So 10, 20, 30. If we want to insert 40, no problem again, insert 40 directly. So at 10, 20, 30, 40, and so on. Now, similarly, if you want to delete, where should I delete? What element should be deleted? If I am inserting from this front end. So the element which was basically, if we are inserting from this end, sorry, we are currently inserting from this end, not from this end. Why? Because the first element which was inserted was 10, then 20, then 30, then 40. So the insertion order is from the last index. Insertion push is from the last index, as we discussed. Both push and pop are from the last index only. So pop will also be from the last index. Pop will also be from the last index. If we want to delete element, first element which is going to be deleted will be the last index. So array dot remove array dot size minus one. We are going to delete 40 and return 40. Next element, delete 30, return 30. Delete 20, return 20. Delete 10, return 10. And finally, array is empty. Array dot size is empty. If we want to again delete, we can return minus one. Stack is already empty. So I guess this simple implementation was clear. Both operations are again constant. This operation is constant because adding in the last of our array list is constant, and getting the element at any index, random index in array list, and removing the last index is also constant. So both operations are constant. So let us implement this. Instead of having an array, in the same question, what I am saying, in the same question, let us have an array list of integers. ARR is equals to new array list. Let us create an empty array list of zero size initially. In the push operation, there is no need to have an overflow condition. Overflow is not required now. We can simply array list dot add value. It will insert in the last. Insert in the last of array list. And since insertion is from the last index, stack means from the same end insertions, from the same end removal. So we will remove from the same end also again. That is in the pop operation. First, we are going to say if top is array dot length minus one. No, there is no top index. If array dot size is zero, if simply this array size is zero, return minus one. This is stack underflow. There is no more elements. Otherwise, first get the element, that is arr dot get of array dot size minus one, and now delete the last element, that is array dot remove array dot size minus one. Maybe this function will also return some value. So let us try if this function is also returning some value. If it will not return any value, then we can do the logic as discussed. So first let us try this. If this array dot remove also returns some value. Okay, so it is good enough. I guess array dot remove is also returning some value. It is actually returning the value which is deleted. The value which is going to be deleted, it is returning that. If we are going to delete 40, the last index, it is returning 40. If we are going to delete 30, it is returning 30. So instead of doing get, then remove, then return val, we can simply return array dot remove. We can simply return array dot remove. So this is like even simpler approach. This is even simpler than what we thought. All the test cases are passing. So this is even simpler approach, even simpler than array. Why? Because we have not to implement, we do not require to implement array list. We can simply use the collection frameworks and we can use the array list implementation. So this was about the constant operation of a push and constant operation of pop, one insertion, one removal using array list, So till now we have discussed two approaches. First approach was using array, fixed size array. Second approach was using dynamic size array, that is array list. Now third approach, which is going to be using the linked list, which is going to use the linked list. So again, linked list is a dynamic. We can increase the size, we can decrease the size as per our requirements. So third is the linked list implementation. Linked list implementation. Linked list implementation of, we can say, of stack. Linked list implementation of stack. Okay. So let us first quickly recap if you do not know what is linked list. So I am quickly trying to discuss how the linked list works. So actually linked list are collection of nodes which have a next pointer. If it is a single linked list, every node have data 10, 20, 30, 40, and every node have a next pointer pointed to it, pointing to the next node. That is 10 will have a next pointer pointing to 20's address. 20 will have a next pointer pointing to 30's node address. 30 will have a next pointer pointing to 40 nodes address. So every node will be containing two things. So if I just first tell you the question name is implement stack using linked list on GFG, there is a stack node. There is a top pointer which is of a type stack node. It is a node type. So what does node type contains? It is containing the data and it is containing the same reference variable, same type of reference variable. Node containing a reference variable of node type only. Node containing a reference variable of node type only. So node having a reference variable of node, of the next node actually. So the next node and the data, there are two things in a linked list. And this is how a linked list looks like. So in linked list, generally what we say, there are two ends of a linked list. There is a head, or we can say that front end. This is the front pointer and this is the tail. So tail is not given to us currently. It is only the head node or the top node which is given to us. So from the top node, from this node, we have to implement a stack. So initially, this is how a stack will look like if we have inserted 4 elements. But initially, how will the stack look like? Let's see. This is how a linked list actually works. But now let's discuss how a stack works using linked list. So initially, top pointer will be null. Initially, top pointer will be null. What it means? There will be no node in the linked list. There will be no node. There are 0 nodes, empty stack. If we want to insert, so first we have to create a node having 10 data, having data is equals to 10. And we have to make the top pointer point to the data, point to the same node only. And the next pointer will be initially pointing to null. Null means nothing. Null means nothing. So initially top will be null. So create a new node, make the data point to val, make the data is equals to val, whatever the parameter we have, and make the next pointer point to null. And initially next pointer will be null only in the constructor. So if you do not know constructor, you can assume next will be null. So next is null. Insert one more node. If we are assuming we are inserting we are inserting from the front end, and we are removing from the front end only. We are removing from the front end. So the next node 20 will be inserted in the front of 10. That is 10 will go back and 20 will be inserted here. If we are assuming front end insertion is there. So 20 will be inserted here. So first create 20 node, and before making this as a new top node, make this node's next pointer point to the previous top. Currently the top pointer is pointing to 10, and we want to insert 20. So how we can insert 20? First, do not make top directly point to 20. Otherwise, you will lose the value 10. 10 खो जाएगा. If you will directly make the top pointer point to the new node, 10 will get lost. So how we can make it insert? How we can make a new node inserted in the front end of the linked list? We can simply say, first, let us make this next pointer of 20, next pointer of the new node point to the top end. And now we can make the top point to the new node. Now we can make the top point to the new node. So now we can say, yes, 20 is inserted in the front. So actually what is happening if I write some piece of code? So first you are creating a new node. A new inserted node will be created. So let us name the new node as maybe temp. So new node is temp. So stack node temp is equals to new stack node, where we are passing the constructor the value which we want to insert. So new stack node temp is equals to new stack node temp value. But how to make it point to the next node? We can say temp dot next should make point to temp top. Temp dot next should point to top when already there is one node. If there is no node initially, if top is a null, if there is no node initially, we can simply make the top pointer point to temp. That's it. In this, nothing you have to do. Just simply make top is equals to temp. Otherwise, you have to do this job. So make the temp, make the new node, make a new node, and this new node will be created before if else. This new node will be created before if else. You have to create the new node always now. Even if the node is the first node of the linked list, or it is a second node or third node, whatever. So you have to create a new node every time. So if this is the first node which is going to be inserted, if stack is empty, so make the top point to temp only. Initially, top was pointing to the new node. But now since it is not the first node, it is the second node. So make the temp next point to top, and now make the top point to temp. Now make the top point to temp. Now top will point to temp. Okay. If we want to insert one more element, again, same job. Is the top null? No, top is not null. It is pointing to some valid node. There is at least one node in the linked list. There are actually two nodes. So do what? First, create a new node. Stack temp is equals to new stack the value. So if we are going to insert 30, we are going to create a new node 30. Now, since else case will occur, temp dot next. Temp, this is temp node. The new node temp dot next is equals to top. Temp dot next is equals to top pointer. So temp's next will point to top. And now make the top point to temp. Make the top pointer point to temp. That is, now this is the topmost element. This is the topmost element. Actually, we are going to do the same job. We are going a similar job as the array implementation. We are having a top pointer. There were we having a top pointer. Now we are having a top node. Top node is there. So currently top node is pointing to 30. Similarly, we can insert more elements, as many as you want. We can insert in the front, because insertion in the front end, if we have the top pointer, is constant operation. This is entire constant operation. This is push operation, which is constant. What is pop operation? Pop operation will also be constant. From the front end, deletion from the front end is very, very simple. It is in fact simpler than we can say insertion. We can simply make what? We can simply first store the value of top. We can make int val is equals to the whatever the element we are going to delete. It is pointing to the top node. So top dot data. We can extract the value from top dot data. And simply deleting it means simply making the top point to the next node. So we can simply make top is equals to top dot next. Top is equals to top dot next. Again, if we want to delete 20, simply delete 20 means first store the value of 20, because we are going to return it. We are going to return the value. So we have to store the value what was deleted. So let's store the value of 20, and simply delete means just make the top point to the next node. Top is equals to top dot next. Top is equals to top dot next. Top will point to top dot next, that is 10. Again, if we want to delete 10, so store the value of 10, store data, top dot data in a val variable. Make the top point to top dot next. So top dot next is null, and return the value. Now, if we want to delete one more node, we cannot delete one more node. Why? Because top is already null. stack is empty. So if stack is empty, if top is null, we cannot delete any more nodes. So we have to return -1 in scenario. That is stack underflow. No more nodes can be deleted. There is actually no more nodes. We have deleted all the nodes. So this was a little bit complex if we do not know array list. Sorry, if we do not know linked list. But if we know linked list, then it is also simple enough. So let us implement it. Stack initially will be null. Initially stack top will be null. So if we are pushing the new node, first we will check if first we are going to create the new node. So stack node temp is equals to new stack node and pass the value, pass the data in the constructor. Now, if this is the first node, so if top is null, we can simply make the temp point to the top point to temp. Otherwise, what we can do, we can first make actually, even if we do this job in both the scenarios, still it will work. Still it will work most probably. So even if you do not do this and just simply make temp dot next is equals to top and top is equals to temp, still it will work. Even if it is the first node, because anyways temp dot next will be top. Top is null initially, so temp dot next for 10 will be null only. So it will still work. So we can simply make top the temp dot next is equals to top. That is make the link first, create the link, and now make the top as the new node. So now make the top as a new node. So this is the push operation. What is pop operation? In pop operation, as discussed, first underflow. If top is null, return -1. Underflow is top is null. If top is null, it is underflow scenario. So return -1. Otherwise, we can delete the node by storing the value which we are going to delete. So int val is equals to the top dot data, and now we can make top is equals to top dot next and return val. We can return the value. So both push and pop are simple enough, but just you have to do a dry run of yourself by yourself, that how linked list is inserting the elements in front, how linked list is removing the elements from front, and you will be able to get the logic how linked list can also be used to implement a stack data structure. This is actually we are going to uh, use linked list. Why? Because linked list is also providing us dynamic behavior. Linked list is also providing us dynamic behavior, and linked list is also non-contiguous. So we can have a lot larger size of linked list. We can have even larger size linked list implementation of stack than comparison with array list. Array list can only be 10 raised per 6 elements, 10 raised per 7 elements, like almost 10 lakh elements, 1 crore elements. But stack using linked list can be even larger. It can store 10 raised per 8 elements, 10 raised per 9 elements, like whatever memory you have. If you have a lot larger memory, it can store lot larger elements because it is discontiguous. So that is the benefit why we have to discuss the linked list implementation of stack. So this was all about stack data structure. This was all about stack, how stack was implemented. First, let us quickly recap. What is stack? Last and first out, same and insertion, same and removal. We can implement it using array. We can implement it using array list. We can implement it using linked list. Both the things, like all the three implementations, both the operations, push and pop, are constant. In array also it is constant. Just in array it is a simple, simple scenario that since array is fixed, since it is of fixed size, there will be a overflow scenario also. In we can say in array list there is no generally overflow scenario, so we can simply make the push operation, just simply add in the last, and delete operations remove from the last. But in linked list also it is similar only. It is both push and pop also constant, but since it is discontiguous, we have to maintain some pointers. We have to maintain the next pointer so that a new node can make point to the next node. That is, as soon as 30 is deleted, now the top should point to 20. As soon as 20 is deleted, top should point to 10. As soon as top is deleted, the first node which was inserted was deleted. Now stack is empty, so top should point to null. So for that, we have to know a little bit of linked list logic, but I hope this logic of temp dot next is top, top is equal to temp in push operation. In pop, top is equal to top dot next. I hope this both operations were clear. Both the insertion and removal are from the front end, because linked list is easier to be implemented from front end. Insertion and removal, insert, that is add or remove from the front end, is easier in linked list. In array list, removal from end and insertion from end is easier. So in array list, it is easier to push from the end and pop from the end, because both operations are constant from the end in array list. And in linked list, both the operations are constant from the front end. That's why in linked list, we are using front end. In arrays, we are using the back end. It is not front end, back end of web development. It is just the rear part or the front part. So I hope this stack implementation was clear. Okay, so we have seen how to implement stack using three methods, that is our array list and linked list. Similarly, we are going to see how we are going to implement our queue data structure. That is the second data structure of our today's free masterclass. So design queue. Actually, what is queue? First, let us discuss what is queue. Then we will discuss what are the various methods in which we can form some queues in Java. So first of all, what is a queue? Queue is a line of maybe entities, line of people, line of students, line of some customers in front of a ice cream parlor. If I am saying there is ice cream parlor, so there might be a line of people which are standing in front of ice cream parlor who want to take the ice cream, or maybe in front of a egg roll shop. So in any you can say any kind of shop, there might be a queue of some people. So let us assume those queue of people is nothing but a queue data structure. Let us see that as a queue data structure. So I am assuming those people are nothing but integers. Maybe they might have been array of heights. This might be an array of students. This might have been an array of money, like first person having 10 rupees, second person having 20 rupees, and so on. So it can be anything. It can be anything. Actually, it is nothing but a simple queue. Now, how does a queue form? How we form generally a queue? When we say we are forming a queue, so initially entire queue will be empty, and one by one, each person will be joining the queue. So initially queue will be empty. 10 will join. Now 20 will join. If I am assuming joining is from the last end. 30 will join. 40 will join. Then similarly 50 will join. So this is how people are joining the queue. This is how the push operation, and which is actually called as NQ operation. In queue, the push operation, the insert operation is known as NQ operation. Insert operation will be from the rear end. If we are assuming it is from rear end. But this is rear end. Rear means back end, last index. But if we want to delete some elements, who is the first element who is going to be served, which is going to be served? Actually, the element which is inserted into the last is not the element which is going to be served first. It is a queue. Queue means first come, first serve. First come, first serve means the element which was inserted in the first position, first in, is the element which is going to be the element who is going to be served. So first in, first out, or you can similarly say last in, last out. So element who was served, who was uh, placed in the front in the starting is going to be served first. So 10 will be served first, then 20 will be served, then 30 will be served, then 40 will be served, then 50 will be served, if you're assuming it is ice cream parlor. So who comes first, he will be served first. Who comes second, he will be served second, and so on. So removal, we can say, is from the opposite end. If NQ operation, insertion operation, is from the rear end, the DQ operation, DQ operation, that is the removal operation, is from the front end. So both the insertion and removal are not from the same end in a queue data structure. Insertion and removal in queue data structure are from different ends. It can be vice versa also. Maybe insertion will be from the left and removal will be from the right, or the insertion is from top and removal is from bottom, or insertion is from bottom, removal is from top. It can be anything. So currently we are assuming it is an array, a simple array. So insertion is from the rear end, removal is from the front end. You can also assume the opposite way. Okay. So if we are assuming like this, initially the queue was empty. So there are actually three ways how we can implement a queue data structure. First way, the types of ways, three ways in order to implement a queue data structure will be a normal array. It will be a normal fixed size array, Second type will be a circular array. So actually in this video, because this video is already like pretty, we can say it has already crossed 50 minutes, I guess. So we are not going to discuss about circular array. We may discuss about circular queue along with the DQ, if you want another lecture, actually, I'm going to plan a video series on this topics that first we are going to see design stack, then design queue, then design DQ, then design the linked list, or maybe design hash map, design heap, design graphs. So we can have a series of design problems based on data structures, designing data structures if you like the series. So if you like it, you can write in the comment section or in the maybe you can go to the Geeksters portal, and on that Geeksters portal you can uh, have some lectures, you can watch some lectures, and you can decide whether you like the content or not, and you can appreciate in whatever way you want. Okay, so coming back, there are three ways. First one is the normal way, second is the circular array, and third way is the linked list. Actually, there is also a way using array list, but array list will be like uh, a little bit complex, because in array list, anyway, we are going to use array only, and we have to do it circularly so that it will be performing better. So essentially, we are going to see these three types. You can also use array list, it is your wish. First way is the normal array, second way is the circular array, third way is using the linked list. So these are the three ways by which we can implement a queue data structure. So let us see the normal array implementation. Let us see first the normal array implementation. Okay. So if we are saying we are going to implement it in a using a normal array of fixed size, let us say fixed 5 size. So n is equal to 5. As we are saying removal, the insertion is from different end, removal is from different end. Initially, if there is no element, so initially where is the element? The first element which is inserted. You can see in this example, the first element which was inserted was the 0th index. So currently both the element front and both the element rear, both the index front and rear will be pointing to the 0th index. Why? Because element which is going to be inserted will be inserted at 0th index, and element which is going to be deleted will be the 0th index only, that is 10 only. So both front and rear initially will be pointing to 0th index. So let us go towards the array implementation. So first is the array, a normal array, not a circular array, a normal array implementation of queue data structure. Those who want to submit it, they can follow this question. Implement queue using array on GFG. Again, it is a basic tag question, but don't worry about basic tag. It is actually a good enough problem, because we are learning from easy topics, stack and queue linked list, to harder topics, that is hash map, heap, graphs. So hash map means a lot of concepts like hashing concepts. A lot of concepts are involved. In heap also a lot of concepts will be involved. So if you want to go till that point, you have to go start from basics, so that your confidence is also built up. Okay, so array implementation of queue. How we can implement a queue using array? Initially, we are assuming the arrays of fixed size. So let us say arrays of 5 size. The queue we want to implement using array. So arrays of 5 size. 1, 2, 3, then 4 and 5. So these are the 5 blocks which are given to us. And again, n is equal to 5. This is the ARR. We want to delete from the different end, remove from the different end. That is the element which is going to be first inserted. First in is element which is going to be removed first. So both the front pointer and the rear pointer, I am showing rear on the top, front on the bottom. The rear pointer will also point to the 0th index. The front pointer will also point to the 0th index. So 0th index, first index, second index, third index, fourth index. C. Now we want to insert elements. So push operation. We want to enqueue elements. Actually, push is nothing but enqueue. So what are they saying? They are saying push. So push is nothing but insert. Insert is nothing but named as enqueue operation in queue. So in push, again, there will be an integer we have to insert. So we can simply say what? We can simply insert the element at rear pointer. Rear pointer, insert the element, because it is inserted from the last index. So array of rear is going to be the value. And as soon as I insert 10 in this element at 0th index, next element, where is it going to be inserted? Where is the next element going to be placed in the queue? In the last pointer only, in the last index only. So we can say rear pointer plus plus. So that next element will be placed at a is the first index, the next index. So we can also say rear plus plus, rear plus plus. Now if we want to insert 20, we can say array of rear is equal to 20, array of rear is equal to 20, and rear plus plus. Okay, good enough. Every new person will be joining the queue in the last only. Anyone will not break the queue and get inserted in the middle unless and until he is a old person and he has a higher priority queue. So rear pointer again 30, insert 30, rear plus plus, insert 40, rear plus plus, insert 50, and rear plus plus. But as soon as we insert 50 and do rear plus plus, if we want to insert one more element, we cannot do it. Why? Because rear is pointing to the last index. Rear is pointing to the last index. Actually, not last index, but rear is pointing to the array dot length. So we can not insert any more element. So if rear is pointing to n, currently it is not circular array. Please do not assume this is circular. This is normal array, non-circular array. So non-circular array implementation we are following. So non-circular array, if rear pointer is pointing to the array dot length, we can simply return. We cannot push more elements because it is overflow. This is overflow scenario. So let me write in red. It is overflow scenario. Overflow. Otherwise, we can insert the element at rear pointer. Okay, very good. Now how to insert some element? How to basically insert this done, but how to remove some elements? So remove or pop or DQ, all these things are same only for in the terms of queue. So from which index, from which end we are going to remove? Insertion is from rear end. This is the insertion order. Insertion order. Removal order from the front end. The insertion and removal are from different ends. First in, first out, last in, last out. So first 10 is going to be removed. That is front element can be deleted. So in push operation, we can simply say front pointing to 0th index. Okay, delete it. So we can say delete. So delete means we can simply return. We can first store the value. We can first store the value of array of front so that we can return it. And then we can do what? Next element after 10 is deleted. Next element after 10 is deleted, logically deleted. Next element which is going to be deleted will be 20. So next element front will be pointing to the first index. That is front plus plus. Simple enough. That is front plus plus. Next element which is going to be deleted will be 20. So front should point to the element which is going to be deleted. Front is the pointer pointing to the first element which is going to be served. The first element which is going to be served. It is the front of the queue. It is the starting person of the queue. So he is the first person who is going to be served. So that is why we are doing front plus plus also. Again, one person should be served. So which person should be served? The front end. That is serve 20. Take the value, do front plus plus and return the value. That is 20 is deleted. 20 is removed from the queue. He is the person who is served. First in, first out, second in, second out, third in, third out, and so on. So again, front plus plus we have done. So we can do front plus plus. Delete 30, front plus plus. Delete 40, front plus plus. Delete 50, front plus plus. And as soon as we delete 50, both front and rear, see very carefully, both front and rear, both are pointing to array.length. So when the rear pointer and both the front pointer are same, we cannot delete any more element. This is a scenario when we can say there is underflow. So if front and rear is the same, if front is pointing to the rear index, there is no more element we can delete. So we can return -1 in this scenario according to the question. See, we can make both front and rear point to 0. We can reinitialize them, but according to GFG, according to the question which we are going to solve on Geeks for Geeks, we are not going to do it. We are going to make them return -1 only when front is equal to rear. What it means, if initially there is no element, front is 0, rear is also 0 initially in the starting as discussed. Both insertion will be at the 0th index and 0th index in the first point, and the removal will also be from the 0th index only. So initially when we say delete a element, when there is no more element, there is no element currently. So front is equals to rear, so return -1. We cannot delete any element. We can insert, but we cannot delete. So at any moment, if we want to basically delete the elements when there is no more element, when front and rear are equal, we cannot delete any more elements. So these are the push and pop operations. So let us quickly submit them. Actually, I have little bit changed the code. Initially, the code was looking like this, but we do not know maybe constructor. So what we have did, we have initialized front is equal to 0. We have initialized rear is equal to 0 initially according to the logic. And we are saying in the push operation, we can simply insert at the rear end. So if rear is already pointing to last index, if rear is already pointing to array.length, we cannot insert any more elements. Return. Otherwise, we can insert according to the logic. So array of rear is equal to val is equals to val. So this is not val, this is x, so make it val. And then since next element will be inserted in the next index, at the next index, so rear plus plus. Similarly, in pop also, in pop operation also, we are doing the same job. Instead of rear, just we are using front. So underflow scenario is front is equals to rear. We cannot delete any more elements. So this is underflow. Already the stack is empty. The sorry, not stack, but queue is empty. So it is empty queue scenario. And this is overflow, which is queue is already full. Queue is already full. So if queue is empty, we cannot delete any more element. Otherwise, we have to delete from the front end. So int the value which we are going to delete will be array of front. And as discussed, front plus plus because next element will be deleted, will be the next index, and return the value which was deleted because we have to return it. So this is the pretty simple logic of implementing a queue using a normal array, a non-circular array. Actually, if you have to make it circular, you have to just change a little bit logic. But currently, this is the logic of queue data structure. This is the logic of queue data structure using a normal queue, using a normal array, a non-circular array. So this is the queue logic. Okay, good enough. Both the operations, the push operation and the pop operation, both the operations are, as discussed, constant operations. Now, let us discuss. First, we have discussed the normal array implementation. Circular array, as I told, I will be discussing. If you want another lecture, I will be taking another lecture on DQ, doubly ended queue. In that, I will be discussing about circular implementation of queue. So currently, I'm skipping this second implementation, but let us go to the linked list implementation because still we have some time left. So still, I guess we can discuss the linked list implementation of a queue data structure. Okay, good enough. So let us say we are going to have the third implementation, actually the second one, which is linked list implementation. Linked list implementation of queue. Okay, so as we know in queue data structure, we have to delete from different and insert from different end. So if we are having a linked list means a node and a next pointer as discussed in stack, a node and a next pointer, a node and a next pointer. So 10 was inserted, then 20 was inserted, then 40 was in 30, then 40 was inserted. So 10 will be having a next pointer to 20. 20 will be having a next pointer to 30's node. 30 node will be having a next pointer to 40 node. And 40 will be having a next pointer to null. There is no next node to 40. So since insertion was from rear end, deletion will be from the front end, or deletion will be from front end, insertion will be from the rear end. It is your wish. Any way you want to do, you can do it. Better will be what? Let us like analyze the scenarios. If we want to delete the front end, this is front end. If I am saying delete from the front end, delete from the front end, or if I am asking you, we have two options. What are the two options? We can delete from first, remove first. We can remove from the front end. In the scenario when we are removing from the first end, that is a front end, we have to insert from the last end, that is add last. Remove first, add last, or the second option is remove last. If we are inserting from last, we have to add from the first. So add first, remove last, or add first. So if we are saying it is a single linked list, if we are saying it is a single linked list, and we have two pointers, the front pointer and the rear pointer, all the head pointer and the tail pointer. If we have these two pointers, front and rear, actually front is the head of the linked list, the starting node of the linked list, rear is the tail node of the linked list. So which option will be better? Will the remove first, add last, or the remove last and add first? Will it will be better? So if you know linked list, remove first, as discussed, is constant. Just simply delete this node by making front is equals to front dot next. Add first is also constant. Remove first is constant, as discussed in stack. Add first is also constant, as discussed in stack. Why? Because we can simply make a new node. We can make the new node's next point to the front node and make the front point to the new node. That is also simple. Head node. Front is nothing but the head node. So that is also constant. Add last. Let us see add last. If we want to insert after 40, if we want to insert 50 after 40, so first create a new node. Make the tail nodes next point to null. No, make the tail nodes next point to the new node and make the tail point to the new node. Now this is the last node of the linked list. So tail will point to the last node and last nodes next will be obviously null initially. So insertion in the last is also constant. Insertion in the last is also constant. Let me repeat the logic how we are inserting. First create the new node 50 which is inserted. Make the tail nodes next point to the new node and make the tail is equal to tail dot next. That is tail will be the last node now. So this is also pretty much simple. We can say this is also constant operation. So add first is also constant. Sorry, add last is also constant. But what about remove last? Remove last means delete the rear end, delete the tail node. In order to delete the tail node, what else change what we need? Can we do rear is equal to rear dot previous? No, there is no previous pointer. So how we can make the rear pointer point to the previous node? How we can make the tail node point to the previous node? We have to only traverse. There is only one way. We have to traverse from the starting node. Go from the starting node and traverse till the second last node. So traversing requires order of n approach. And also we have to make the 30s next point to null. So that is also will require the traversal. So remove last is not constant. It is linear. So which option will you prefer? Will you prefer remove first and add last? Both are constant. Or will you prefer remove last and add first? In which add first is also although constant, but remove last is linear. So obviously we will not prefer linear traversal. One single removal operation as linear operation. No. One single operation constant, removal, one single addition operation also constant. So it is optimized. This is optimized. So we are going to use remove first, add last. We are going to remove first, remove from the front end, remove from the front end, and insert in the rear end. Add last, remove first. Okay. So we are going to use what? We are going to have two pointers, tail pointer and front pointer. Remove first is simple enough. So let us implement the queue using linked list. There is front pointer, there is rear pointer. Both are initially null null. Push. If there is no node in the linked list, if front is null, if front is null or rear is null, if there is no node in the linked list, this is the first node which is going to be inserted. So first create the node. This is now not a stack node. This is a queue node. Queue node is containing data and the next pointer. So queue node first create a new node which is temp is equals to new queue node and store the data, store the value in this. Okay. Now, if this is the first node which is inserted, if front and rear are null, so make both the front and rear point to the same node. If there is no node, the first node is the starting node and the ending node. If there is only one node, this is the starting point and the ending point. Otherwise, if this is not the first node, so where we are inserting? We are inserting in the last. How we are inserting in the last? We are making the tail dot next is equals to the new node and tail is equals to tail dot next. So we are first making the rear dot next is equals to the new node, the temp node, by making it point to it. And now we can say the rear is now the new node. So rear is equal to rear dot next, or you can say rear is equal to temp. It is your wish. Any way you want to write, you can write it. So first make the rear dot next is equal to temp. As I discussed, if we want to insert 50 in the front, sorry, in the rear, in the last. So first create the 50 node, make the rear pointers next point to what? Point to the new node. Rear dot next is equals to temp. And now, since we have inserted this, now we can say rear is equals to the new node. That is rear is equals to temp. That is what we have done. Rear dot next is equals to temp, and now rear is equals to temp. Okay, so this is simple push operation. In pop operation, what we are going to do? In pop operation, since pop is from front end, and we have already discussed deletion from front end. So if we are going to delete from front end, we can simply make what? We can simply make front is equals to front dot next. But before deleting, before making front is equal to front dot next, we have to also check if front is already null. If front is already null, there is no more node which can be deleted. So return -1 in that scenario. And also we have to return the value which we are deleting. So val is equals to front dot data. Now we can make that node deleted by making front is equals to front dot next. I am not repeating this because we have already discussed in stack. Add the remove first operation. So front is equals to front dot next. And now we can return the value. So this is simple approach of pop operation. So let us discuss, let us run the code and check whether it is working fine or not. Sample test case is working fine. Let's submit also. Okay, so all the test cases are passing. So this is a simple code of implementation of queue data structure. Dynamic queue, a queue which is of changing size, growing queue, shrinking queue according to the need. If we have to implement a queue of 10 size, we can implement a queue of 10 size. If we want only 5 elements, we can reduce the number of elements in the queue because it is using a linked list. It is using a linked list. So this is a linked list having two pointers, front pointer and a rear pointer. We require two pointers in this logic. So insertion is constant, as you can see. This is just equal operations like assignment operations, and here it is also constant operation. It is again some assignment operations. So both are, we can say, constant operations. So using linked list is also constant. Using normal array was also constant, but the third approach will be using the circular queue. That will also be constant. That is little bit trickier. So I'm not going to discuss it this in this video. Maybe you can try it using circular queue on lead code. The question is lead code 622. If you want, we can have another session. If you understood the today's session, you can have a demand that we want a new video. We have to have a follow-up of designing a circular queue, designing a doubly ended queue, implementing stack using queue, implementing queue using stack. So we can discuss all of these questions in one more video, in one more, we can say, in one more free masterclass. Okay, so that was all about what we can say all about stacks, queues, how to implement stacks, how to implement queue. These are the two basic data structures we usually use. And there are a lot of questions which we generally solve using stacks. For example, the next greater element questions, the parenthesis problems. In queue also there are a lot of problems. Queue basically is the fundamental for graphs. In graphs, we use level order, or in trees also we use level order. So queue is the fundamental thing for level order and breadth first traversal in graphs. So these two data structures are very, very important, both in terms of data structure algorithms and in terms of real life also. In real life also, in development also, we use these data structures. I hope you got the logic, you got the entire logic of how we are designing a stack, we are designing a queue. So I want to discuss one more point related to Geeksters content which Geekster is bringing for you. So have a look at the Geekster's content which they are bringing for you. You can check check it out for free. There is no cost associated with it. It is free of course. So if you like it, you can maybe enroll it. You can enroll in the paid batches. You can enroll in the post-paid batches. In any fashion you want, you can enroll. There are prepaid batches, there are post-paid batches. But essentially, I am going to show you some free lectures, some free master classes, some free resources which you can check out, which are provided by Geekster.